Hello guys and welcome to Maths and Science Academy. Today we will be looking at part 2 of Analytical Geometry. Buckle up and let's get into it.
Question 4's statement reads as follows. In the diagram, the circle centered at C, 2 and P is drawn AA with coordinates 5 and 1 and B with coordinates -3 and -3 are the points on the circle. E is the midpoint of AAB.
Question for point 1. Calculate the coordinates of E, the midpoint of AAB. Using the midpoint formula, we are going to substitute the coordinates of AA and B, giving us x of AA as 5 plus x of B as -3 all over 2, and y of AA as 1 plus y of B as -3 all over 2. 5 minus 3 over 2 equal to 1, and 1 minus 3 over 2 equal to -1. Therefore, coordinates of E are 1 and -1.
Question for point 2. Calculate the length of AAB. Leave your answer in surd form.
We will be using the distance formula, x of AA as 5 minus x of B as -3, giving us 8 squared, plus y of AA as 1 minus y of B as -3, giving us 4 squared. Therefore, the length of AAB will be for root 5.
Question 4.3. Determine the equation of the perpendicular bisector of AAB in the form y equals mx plus c. This perpendicular bisector will then be CE from Theorem 1 of Euclidean geometry. Line drawn from the center of circle to the chord bisects the chord and is also perpendicular to the chord.
Firstly things first, since we know that CE is perpendicular to AAB, we have to find the gradient of the perpendicular bisector. The product of the gradient of each line is equal to -1.
Now using the gradient formula, we are going to calculate the gradient of AAB, y of AA as 1 minus y of B as -3, giving us for all over x of AA as 5 minus x of B as -3, giving us 8.
Which is equal to 1 over 2.
Therefore, gradient of AAB times gradient of CE equal to -1. Since we know that CE is the perpendicular bisector of AAB.
And the gradient of AAB as 1 over 2 times m, 2 equals -1. Therefore, the gradient of the perpendicular bisector will then be -2. Since we know the gradient of the perpendicular bisector, given as m, 2, we will then ask the coordinates of E as 1 and -1 lying on the line CE to find the constant C.
Giving us -1 equals -2 times 1 plus C. Therefore, C is equal to 1. Therefore, the equation of the perpendicular bisector is y equals -2, x plus 1. Question 4.4. We are supposed to show that P equals -3.
We are going to use the gradient of CE, the perpendicular bisector, and we know that the gradient of CE is equal to y2 minus y1 all over x2 minus x1. Equal to y of E as -1 minus y of C as P all over x of E as 1 minus x of C as 2. Equal to -2 over 1. 1 minus 2 is equal to -1. Then we cross-multiply fractions, giving us 2 equal to -1 minus P. Equal to P equal to, transpose -1 to the left of the equal sign, giving us P equal to 3. Mind you, we only transposed -1 to the left of the equal sign. P is actually negative. Dividing by negative, therefore P equal to -3, QED.
Question 4.5. We are supposed to show by calculations that the equation of the circle is x squared plus y squared minus for x plus 6, y minus 12 equal to 0.
By the aid of the equation of the circle, x minus AA all squared plus y minus b all squared, equal to the radius of the circle squared, where A and B are the coordinates of the center of the circle.
A as the x-coordinate of the circle, which is equal to 2, and B as the y-coordinate of the center of the circle, P equal to -3.
Now we're supposed to determine the radius of the circle. And we know that a radius is a line drawn from the center of the circle to the circumference of a circle, of which in this case, AC or BC. But let's use AC, and let's determine the length of this radius.
Using the distance formula,
AAC squared equals to R squared equal x of AA as 5 minus x of C as 2 all squared plus y of AA as 1 minus x of C as P equal to 3 all squared. 5 minus 2 is equal to 3 squared, which is 9, and 1 plus 3 is equal to 4 squared, which is 16. 9 plus 16 equal to 25. Therefore, the length of the radius squared, R squared, is equal to 25. Now we are going to expand and simplify x minus 2 all squared and y plus 3 all squared. Pause the video and simplify on a piece of paper.
We then get x squared minus 4x plus 4 plus y squared plus 6y plus 9 equal to 25.
We will then transpose 25 to the left of the equal sign, giving us -25. You will now punch 4 plus 9 minus 25 on your calculator, giving us -12.
Hence, writing minus 12, x squared plus y squared minus 4x plus 6y minus 12 equal to 0 as our final answer. Lastly, question 4.6, calculate the value of t for which the straight line, y equal to tx plus 8, will not intersect the circle. Looking at the given equation of straight line, y equal to tx plus 8, 8 is actually the y-intercept of the straight line, and t represented the gradient of each line, either positive gradient or negative gradient of each line.
Let equation 1 be the equation of the straight line and equation 2 be the equation of the circle. We then substitute y equal to tx plus 8 into the equation of the circle, giving us x squared plus into tx plus 8 all squared minus for x plus 6tx plus 48 minus 12 equal to 0. Now let's expand and simplify tx plus 8 all squared, giving us x squared plus dx all squared plus. We know from the law of exponents a b squared all squared is equal to a squared times b to the exponent 4. When multiplying tx all squared, we will then be using this law of exponent. Now let's continue our expand and simplify process. Tx all squared plus 16tx plus 64. Minus for x plus 6tx plus 48 minus 12 equal to 0. Now let's use the law of exponent on tx all squared, giving us x squared times t squared. Considering plus 48 minus 12 plus 64. And punching out 64 plus 48 minus 12. On your calculator, you will then find the answer to be 100.
Now grouping like terms 16tx plus 6tx, giving us 22tx.
Now let's factorize by taking out the common factor x squared. From x squared plus x squared times t squared, giving us x squared into 1 plus t squared. And taking out x from 22 tx minus 4x, giving us x into 22 t minus 4. Plus 100 equal to 0.
Now, 1 plus t squared will then be a. 22 t minus 4 is our b, and 100 will then be our constant c. And from nature of roots, delta is not supposed to be equal to 0 since the two equations don't intersect anywhere. Hence we know that delta is equal to b squared minus 4 a c, which is not equal to 0. We also know that b is equal to 22 t minus 4 all squared, minus 4a, and we know a is equal to 1 plus t squared, times c, whereby c equal to 100, which is not equal to 0.
Now let's expand and simplify 22t minus 4, all squared.
Punching 20 to squared on your calculator, giving us 484.
22t all squared will then be 484t squared.
Minus 22 t times 4, the product of the two terms times 2.
Now punching 22 times negative 4 times 2 on our calculator, we get negative 176. These implies negative 176t.
And negative for squared is equal to positive 16. Negative for times 100 gives us 400, and 400 times t squared giving us negative 400 t squared, which is not equal to 0.
Now grouping like terms, 484 t squared minus 400 t squared gives us 84 t squared. Minus 176 t. And 16 minus 400 gives us negative 384, which is not equal to 0.
Now we can see that this is a quadratic equation using the quadratic formula negative b plus or minus b squared minus 4a c all over 2a. We will then substitute values of b, which is negative 176a, as 84, and c, which is equal to negative 384.
Substituting into our quadratic formula, minus b, whereby b is equal to negative 176, plus into square root of b squared, as negative 176 all squared. Minus for a, c, which is then minus for times 84 as our a, times negative 384 as c, all over 2 times 84, giving us 20 for over 7. Therefore, our positive gradient will then be t equal to 20 for over 7. Using the negative sign to find the negative gradient, the quadratic formula gives us negative for over 3. Therefore, our negative gradient will then be t equal to negative for over 3.
Since we have already found the two values of t, this will then be our critical values using the number line. Negative for over 3 will be on the left side since we start from the smaller number to the big number, hence 24 over 7 in this case will be on the right side on the number line.
We will be starting from the left of the number line, looking for a number less than for over 3, of which we can then use negative 10, substitute 10 into our equation, giving us 84 times negative 10 squared, minus 176 times negative 10 minus 384, giving us positive 9,776, of which now we know from negative for over 3 to the left, all answers will be positive.
Now choosing 0, which is in between 20 for over 7 and negative for over 3.
Substitute into our equation as 84 times 0 squared minus 176 times 0 minus 384, giving us negative 384.
Now we know that all answers in between 24 over 7 and negative for over 3 will all be negative.
Now looking for values greater than 20 for over 7, we choose 20.
And substituting 20 into our equation as 84 times 20 squared minus 176 times 20 minus 384, we get our answer to be positive 29,696.
Now we know that for all values greater than 20 for over 7, we all be positive.
Now let's illustrate the graphs of the two straight lines and the circle given if they intersect. Let's start with the negative gradient straight line, y equal to negative for over 3, x plus 8. Secondly, the equation of the straight line with a positive gradient given as y equal to 24 over 7, x plus 8, as illustrated. And lastly, the equation of the circle, x squared plus y squared minus 4x plus 6y minus 12 equal to 0.
And from delta less than 0, simply meaning that delta has been negative, and we then can see from the number line that for t greater than negative gradient for over 3, all values are negative. And also for t less than the positive gradient 20/7, all values are negative.
20 for over 7, which is approximately 3.42, negative for over 3, is equal to negative 1.33.
From this graph simulation, we can see that for t greater than 1.3, let's start with negative 1 to 0.9, to 0.7, and again to 0.6. Looking at the red straight line, the line moves away from the circle.
Now let's look at the simulation of the straight line with the positive gradient shown in blue. Since the gradient has to be less than approximately 3.42, let's start with 3.4 to 3.2 to 3.1 to 2. We can eventually see that as the gradient t become less and lesser than 27/7, which is approximately 3.42, the straight line moves away from the circle.